Welcome back, everybody. For this section, we talk about volcanoes in Arizona, ? The answer is yes, there are a ton of volcanic sequences, volcanic products, rocks in Arizona. Most all of these, if you look at your map here, are going to be red, orange, and yellow. This corresponds to very young, to medium old, to, okay, getting a little bit older now. Everything from about 38 million years to the present. So this is after the dinosaurs have gone extinct, but long before human beings have gotten there. At about the halfway point here is where this really picks up, about the same time as what? Well, it's about the same time as the Basin and Range Province forming. Yep, there's no escape on this one. So you have crustal thinning and extension as the crust here pulls apart. As a result of the crust pulling apart, there's a sort of vacuum underneath it. Hot material from the mantle rises, and so you have volcanoes in Arizona. Arizona does have one sort of classic cinder cone type volcano called SP Crater. You do have to go a little bit off-road if you want to hike this one, but it's not too bad. As far as finding it, so you have Flagstaff here, you go up north. This is SP Crater on the map, and here is Sunset Crater, the next one we'll talk about here. So Sunset Crater is another cinder cone type volcano. If you look, you see it's relatively steep, it's not too big, and it has this pronounced sort of cone of depression at the top. Going to be northeast of Flagstaff, about 1,000 feet tall, hasn't erupted in about 1,000 years. And when it did erupt, it's believed that this basaltic magma would have mixed with rock and then exploded violently as the water heated up, turned into steam. Steam wants to expand outward, so we get an explosion, one that would have reached about 850 feet into the air. Okay, so we have this violent eruption, lava is spewed up into the air, it comes back down, cools off, crystallizes, forms these little rubbly bits called cinders. And this happens over and over again until the rubble sort of piles up into a cone shape. Now, Sunset Crater also produces lava flows. These are going to be type lavas, including the Bonito and Cana lava flows, which you can see in some of the pictures here, including this one, which we've seen previously in these lectures. We talked about how there are volcanoes in Flagstaff. This is actually Sunset Crater that we were looking at for this. Now, it's not just cinder cones here. We also have more intermediate to composite type volcanoes, including the San Francisco Peaks. These are also going to be in the Flagstaff area, created by many eruptions within about the past 500,000 to million years. And at some point, not sure exactly when, the mountain would have blown its top off. And whereas you used to have one mountain coming up here, all of that was blown off, and now you have this series of several peaks, including a series of eroded valleys, which have been carved in where the mountain once stood. So to put a visual, this is what it looks like now, and this is what it looked like then, much taller. So the highest point today is a full 2,000 feet lower than what it would have been before this massive eruption. And after you have a volcano that blows its top off like this, it exposes a lot of sharp edges, jagged stuff up into the sky, tends to weather and erode really, really quickly. You have a lot of erosion that has taken place in the inner basin since then. There's also the matter of elevation here. So because it is so high up in the San Francisco mountains, it's very likely that there was glaciation here during the most recent ice age. Not confident that all of Arizona would have been covered, that seems very unlikely, but at least this part of it would have had an ice sheet on it, would have been taking part in the ice age. And part of the evidence here is that you have these glacial rock deposits in the mountains, so-called moraines, that have been left behind by the glaciers. So in terms of the larger geologic context, what is going on here? Why are these volcanoes here? Well, it's not just the Basin and Range extension, but in Flagstaff area specifically, you have this whole San Francisco volcanic field. This is a result of hotspot activity. It includes SP Crater that we've talked about, San Francisco Mountains, everything up here in the Flagstaff area, huge area, 5,000 square kilometers, all, maybe active for the last 6 million years or so due to hotspot activity. And that's 6 million years, just like the last number in the access code, which is 6. Last digit is 6. But wait, there are shield volcanoes in Arizona as well. There's one called House Mountain. You can see, obviously, it looks like a house. This one is a shield volcano about 6 miles southwest of Sedona. This one is more recent than the Basin and Range. Basin and Range is 30 million. This one is about 15 million years ago. And you can actually see basaltic lava flows here in person if you like. And here, a little bit closer to home, maybe 50 miles east of Phoenix, are these, the Superstition Mountains. And these are the remnants of a supervolcano complex that would have been here about 18 to 25 million years ago. So you take time the dinosaurs went extinct, take modern day, and you about split the difference. That's when this would have happened. And this would have been, like most supervolcanoes, maybe 1,000 times as much as Mount St. Helens. If you've seen videos, terrible things that happen with that eruption, multiply about 1,000 and you get, maybe 2,500 cubic miles of ash and lava emitted from whatever it is that created this. It's believed the volcanic ash from this may have reached it as far as Arkansas and Louisiana. A lot of ash. So what is the process for forming this? Well, we have our big eruption here at the end, tons of material which exits the volcano by force. And after that, you have the collapse of the innermost part of the volcano, the caldera. So all this material that was inside the volcano is now been spewed out, and it leaves, this hole. The caldera collapses down into this hole. But later, because magma is still pressing against it from the bottom, it starts to re-emerge and it starts to buckle and form this sort of dome shape. And you can't exactly see the dome, but maybe you can see kind of the dome here. It's exactly what is happening here in the structural resurgence of it. And now the caldera itself is very, very hard to see here. There's been so much erosion, but this process is exactly what happened here. So now, if somebody showed you a map like this of the world, you would know where the plate boundaries are, what those plate boundaries mean, what the plates themselves are made of. You would be able to answer questions about earthquakes, where they occur and why. You would be able to now answer questions about volcanoes. Why are they located where they are? What types of volcanoes would you see? What are these things called hotspots? Everything here on this map you would be able to explain to somebody who has not taken this class. You would also be able to now zoom in on parts of the rock cycle. So here where we have our extrusive igneous rocks, here where we have our intrusive igneous rocks, you know what kind of rocks would be formed here, what the processes look like, how the rock materials move from one reservoir to another here, as well as how the melting happens. So what are the big ideas for this section? First, differences between magma and lava, basics. Where does magma come from? How does it melt in the first place? Is it from deep within the earth? Is it from the crust? Where exactly does it melt? How do the melts get to the surface? You'd be able to talk about igneous rock textures. If you're out in the field and you see something with visible grains, really big crystals on something, you now know exactly what this means, the likely history of that rock. You know something about extrusive hazards, so the most dangerous parts of a volcano, which types of volcanoes tend to be the most dangerous and why. You would know the different types of volcanoes which exist and maybe be able to give a couple examples of each. And there are more of these included in the PowerPoint than I have in the video. Lots of extra slides with pictures and locations on this one. Finally, you would be able to talk about the Arizona volcanoes in some detail, why they are located where they are, what the larger setting is, and how each one of them formed. That is all I have for you. Thank you.